Myself, Professor D.S. Rai, Professor, Department of Civil Engineering, BBD, IITM, Lucknow. Now, welcome to the class. Today, we will discuss KCE 602 Transportation Engineering, in which we will discuss lecture number 28, in which we will discuss the pavement and design factors. The reference book that I have taken, that is Highway Engineering from Khanna and Gisto. Principle of Transportation Engineering, Partho Chakravarti and Imesh Das. Pavement Design from R. Srinivas Kumar. Building Materials from by the S.K. Duggal. The contents of today's lecture are type of pavements, design factors, design loads, maximum wheel load, contact pressure, load repetition, subgrade soil, climatic and environmental factors, pavement component of materials, a special factor in design of different type of the pavement. So, we will discuss one by one. First of all, the type of pavements. Based on the structural behavior, there are three types, generally there are three types of the pavements. One is flexible pavement, second is rigid pavement, and third is a semi-rigid pavement. Flexible pavement, in which on the wheel have a low or negligible fractural strength. Means, suppose a wheel load is coming on the pavement surface, there will be some deflection on the flexible pavement. As the load removed from that point, the shape of the pavement will regain its own shape as original. So, this is the flexible pavement. Flexible in their structural action under the load. A layered system comprising of different layer of the pavement, means this is wearing coat, base course, sub base course, and this is subgrade. Subgrade. So, this is the layer system. Now, load transfer by grain to grain in the flexible pavement through the granular structure. The stress on the subgrade kept low within the permissible limit, bearing permissible limit within the bearing power, that is called CVR, a CVR value. Excessive deformation of subgrade are restricted. So, these are the various properties, you can say, of the flexible pavement. Say this is a typical cross section of a flexible pavement. Here the area of tire contact, so this is the wheel load, and these are the different layers. This is the wearing surface, base course, sub base course, subgrade, and load transfer from the top of the pavement system and goes to the lower layer by grain to grain, means here the load is transferred load is transferred from here to here. So, the load is transferred as goes lower, the stress, because area is increasing. So, the stress will be obviously decreased. So, up to the junction or junction of the sub base and subgrade, the stress becomes very low, and it should be less than the bearing capacity of the subgrade. Otherwise, there will be chances of failure of the pavement system. So, the subgrade, a layer of a natural soil prepared to receive the layer of pavement material placed over it. Load of pavement and the vehicle are ultimately received by the soil subgrade and dispersion to the earth masses. Top 50 centimeter, subgrade layer should have good CBR. As per Morse specification, below the sub base, next layer is a subgrade, subgrade, which is called 50 centimeter thick layer is called subgrade. Soil subgrade is over stress not to cause excessive stress condition or temporary deformation, not deform beyond its elastic limit. Higher CBR means less pavement thickness. So, the construction cost will be lesser. Low CBR, more pavement thickness and the construction cost will be more. So, it is necessary to modify the subgrade soil. Now, this consists sub base and base. To improve load supporting capacity by dispersing the load through a finite thickness. To provide a stress transmitting media to spread the wheel load in such a manner as to prevent shear and consolidation deformation. A well compacted granular structure consisting of a strong graded aggregate can transfer the compressive stress through a wider area in shape of truncated cone. This is the truncated cone. This is the truncated cone through which load is transferred to the soil mass. Now, rigid pavement. Base course under the rigid pavement preventing pumping action against the under the rigid pavement, protecting subgrade under the frost conditions. Now, the wearing surface in the rigid pavement to provide a smooth riding quality, to resist pressure exerted by the vehicles, to taken off wear and tear due to traffic and environmental conditions, to provide watertight surface against water surface infiltration. This is a typical cross section of a rigid pavement. This is the quality pavement concrete, quality pavement concrete. This is the main concrete work. This is the base course and this is the soil subgrade. So, this is a typical cross section of a rigid pavement. This poses a noteworthy flexural strength or fractural rigidity. A stress not transfer from grain to grain. Here in flexible pavement load is transferred grain to grain, whereas in rigid pavement it is not transferred by grain to grain. have a slab action and is capable of transferring wheel load stress in the wider area. Tensile stress developed due to bending action of the slab under the wheel load and temperature variation, more economical in longer time, and not get deformed to the shape of lower surface as it can bridge the minor variation of the lower layer. In flexible pavement, if there is any deformation, then the top layer will also deform accordingly. But in the rigid pavement, if there is a small deformation under the pavement surface, then there will be no deformation on the top surface. So, this is the advantage. Of course, the visibility of this pavement in night is very good as compared to the flexible pavement. The pavement design consists of two parts. First is mixed design of material to be used in each pavement component layer, and the second design of pavement thickness and the component layer. The factors affecting the designs are design wheel load, subgrade soil, climatic condition, pavement component material, environmental factors and a special factor in the design of different type of the pavements. Now, design load. Design thickness of the pavement depends upon the design wheel load. Higher wheel load need higher pavement thickness. Following affect the consider into the accounts while considering the design wheel load: maximum wheel load, total static load on wheel, each wheel, multiple lead assembly, that is dual tandem wheel load, equivalent single wheel load, contact pressure, load repetition, dynamic effect of transient loads. So, these are the factors that are considered while designing. This is the maximum wheel load. This is the axle of dual tire on both sides. Here the single axle have a maximum wheel load of 80 kilonewton or 8160 kg or 18,000 pound or 18 kips. These are the different units, and the center to center distance between the wheel is 310 mm. The tire pressure in each tire shall be 0.56 megapascal or 5.6 kg per centimeter square. The maximum legal axle load as per IRC is 8170, meaning 80 kilonewton, and the maximum equivalent single wheel load will be 4085, half of this one. This is the configuration of different types of axle. Single axle, so it is called single axle single wheel because one wheel is there. This is tandem axle, means there are two axle nearby each other, tandem axle single wheel. This is tandem axle dual wheel, two wheels in each side. This is the single axle dual wheel, and this vehicle has 5 axle tractor semi trailer. So, these are the different configuration of the axle. Now, equivalent single wheel load, it is very important. The effect on the pavement through a dual wheel assembly is not equal to 2 times of the load on any one of the wheel, means it is not equal to P plus P, means 2P. Why? The inference of wheel load overlap after d by 2 from the top of the pavement. So, after that up till now, if you are going to add the total load up to d by 2, then the total load will be 2 p, p plus p. But if the inference of this will goes beyond d by 2, then the partial stress will be overlapped, and in this case this will not be A equal to 2 p. So, the effect on the pavement through a dual wheel assembly is not equal to 2 times of the load on any one of the wheel. The equivalent single wheel load may determine based on equivalent deflection or stress criteria. By these two criteria, deflection criteria or stress criteria, the effective loading is calculated. Now, the come to the contact pressure. This is the contact pressure of the tire to the pavement surface. This is the pavement surface. So, this is the contact pressure. It is not exactly the width of the wheel. There is some cambered like this way dual tire contact area on the pavement surface, and it may assume a contact radius or circular equivalent radius contact area of radius A. It is assumed it is a circular one. Now, the vertical stress, we can see here the vertical stress, as here the stress is very high, 14 kg per centimeter square, from 6.5 to 14 kg per centimeter square. But as we go below the pavement surface, the stress is reduced very sharply, and see here at 25 centimeter below the pavement surface, the stress is nearly 1.2 kg per centimeter square in this case, and this is more or less same. So, this is the 18 ton 14 kg per centimeter square. There are different loadings 16 tons, 36 tons, 36 tons, 1.8 tons means 7 kg per centimeter, 7 kg, 14 kg per centimeter square. Means as we go below the surface level, then the stress will be goes on decreasing with a faster rate, even a faster rate. Now, come to the contact pressure. This is the tire pressure. The tire pressure and contact pressure are different. In tire pressure, the pressure exerted by the air in the tire, whereas in the contact pressure, the area will be slightly lesser. So, here the contact pressure may be higher or lower depending on the pressure in the tire. So, see here this is the 45-degree line. So, here 7 kg and this is the point where contact pressure, tire pressure and the contact pressure will be same. Below that the contact pressure will be lesser as compared to the tire pressure. This is the load repetition. Deformation of pavement and subgrade due to single application of wheel load may be small. Means suppose a vehicle is going on the road, and if it is overloaded also, then also there will be no damage on the pavement surface, and there will be no deformation of the pavement surface. Due to repetition application of the load, load, there would be a increase in magnitude of plastic and elastic deformation and may cause pavement deformation and result pavement failure. So, the number of repetition is the very important factor as far as pavement design is concerned, and so it is, you can say this is the fatigue failure. This is a graph, this is the repetition 10, 10 square, 10 to the power q, 10 to the power 4, 10 to the power 5, 6, 7, 8, and this is the pavement thickness 5, 10, 15, 20, 25 and so on 45. See here, these are the number of lines here 25 centimeter thickness. These are the lines which cut each of the loading at 25 centimeter thickness. So, as repetition go on increasing, the thickness will require more. We will discuss it in the design part of the flexible pavement, the effect of the repetition. Now, design factor, dynamic effect of transient load. Dynamic effect of transient loads applied by a moving vehicle is combination of a static load and transient dynamic load induced by tire. Is it? So, the intensity of transient dynamic force induced by the moving tire will be characteristics of pavement surface such as unevenness, roughness and other distresses. The vehicle characteristics such as gross weight, tire pressure, suspension system, body conditions and age of the vehicle. The climatic conditions such as temperature and precipitation also affect the dynamic effect of transient load. Simple meaning of transient load is combined effect induced by the static load and the moving load. Now, subgrade. The property of subgrade are important in deciding the required thickness of the pavement. First of all, there are some function of the subgrade. First, it is a structural part of the pavement. Second, finally, it receives all loads coming from the vehicle and its loading. Third, it provide a proper filtration media for drain of water if coming from anywhere into the pavement surface. And fourth, it provide cut off capillary water coming from the bottom to the top. So, these are the basic requirement for the subgrade. So, subgrade is the not a neglected item of the pavement system, but it is a one of the most important factors, because this will decide the load coming on the pavement surface, how it will behave. Now, the design factors, climatic and environmental factors, the intensity and duration of rainfall, fog, snowfall, temperature of air and pavement, surface and subsurface drainage condition, type of topography and soil type, water body nearby, groundwater level, intensity of wind, cloud coverage, relative humidity, moisture, frost action and mud pumping. So, these are the different climatic and environmental conditions. See here, this is a total environmental conditions that will prevail in the design factor. This is a night time where the temperature stresses are providing variation widely. At daytime, the sun will provide higher temperature and produce higher stress in the pavement surface, especially in the rigid pavement. This is the rain, the cloud coverage, and in cloud coverage there will be humidity. This is the wind. Wind is also a very important factor, because as per IRC quote saying that if the wind speed is more than 40 kilometer per hour, then we have to stop all type of construction going on the pavement. As it, this is the water seepage to the ground. Of course, this will create distresses on the pavement surface. This is pond nearby the pavement surface, and that the water may percolates into the subgrade and finally failure of the pavement system. The temperature of air and the pavement system and humidity. Now, this is the capillary rise of the groundwater. So, if the capillary rise will go up, this will damage the entire pavement system. So, our subgrade material should be such that should provide a cutoff for the capillary action, means granular material should be placed into the subgrade, and this will provide a drainage, a proper drainage, and it will not allow water to go up. So, this will provide a capillary cutoff, and this is the groundwater, natural the groundwater. This is the surface, this is the original surface, and due to distresses, this is the undulated surface shown here. This is the original level of the surface, this is the original level of the surface. The distresses developed due to many reasons. Here is the wind surface, means this surface has been broken out, and the frost heaves, means if water percolates inside the pavement system by any means, and if temperature goes down beyond 0 degree centigrade, then that water will convert into the ice ball, and of course, we know the volume of ice is more than the water, and of course, if the volume will increase, then finally that will be adjusted by breaking the surface. So, if by any means water goes inside the pavement system, that will finally break the surface due to frost heave. Design factors, design component materials. Stress distribution characteristic of pavement layer component depends on the characteristic of the material. Fatigue behavior of the material and their durability under the adverse conditions should be given due consideration. Special factors in the design of different type of the pavement. In case of semi-rigid pavement materials, the formation of shrinkage crack that should be take care of, pattern and mode of propagation of the cracks, fatigue behavior of cracks such as hairline cracks, etc. So, these are the special factors that should be considered while designing the either flexible pavement or the rigid pavement. So, this is the end. Thank you very much.